Going to do a quick video lecture here to show you how to use Logger Pro in case you don't already know. So once you've downloaded the program and installed it on your machine, you can open it. The icon for it is this piece of paper on the bottom. So you let the program open, and then we want to put some data into the data table. So I had some data up on the board in class today that you may have seen. We'll talk more about what it is in a second, but let's say I measured the mass and volume of some solutions to determine protein concentration. So let's say that here are the values. And you'll notice as I'm putting in 2.0, it's changing to 2. So there are a couple things I want to do with this data. If I double click on the column, I can do a couple of things. First of all, I can name the column. So these are going to represent masses. So I would name the column mass of protein. The short name I would maybe call mass, and the units are grams. And then if I click on options, I can say that I want there to be two significant figures. So right now, if I click on significant figures, I can say that I want there to be two significant figures. And then I hit done. And then I want to do the same for the Y column. So this data that I've collected, if I click on column definition, this tells me about the volume of the solution, short name, volume, and the units that I measured the volume in was milliliters. Again, if I want to display two significant figures, I click significant figures and then 2, and when I hit done, I see that there are now all of the volumes are 2.0 and show that there are 2 milliliters. So now what I want to graph is not the mass versus the volume, but instead I want to graph the concentration versus the absorbance. So when we talk about concentration, concentration is a calculated value, the grams over the milliliters. So I could calculate these values on my own. I could see that the first solution has a mass of 20 and a volume of 2. So 20 grams per 2 milliliters is a concentration of 10. Instead, I can have the computer do this for me. So if I go to Data, New Calculated Column, I'm going to call this column Protein Concentration. The short name can be concentration, and the units will be grams per milliliters. And now I need to tell the computer how to calculate it. So down here in the equation box, I'm going to click, in order to calculate this, I need to do the mass divided by the volume. So I'm going to, in the variables, click mass, and then divided by volume. And then when I hit done, I see that a new column has appeared. So now it's hard to see everything in the data set, so I'll just expand the data table a little bit so that we can see everything that's there. So here's the mass column, and we have the volume column, and now we have our new calculated column, which is the concentration. So this is how you can use the Logger Pro to calculate the density for you by putting in your mass and volume measurements and then typing the formula for density, which is mass over volume, into the calculated column formula. I also want to put a column in here for absorbance because in this experiment that I'm showing you now, I measured the absorbance of these solutions of varying concentration. So if I go to Data, a new manual column, I'm going to call this absorbance, the short name ABS, and actually absorbance has no units. So if these will be some values that I recorded directly in the lab, 0.11, 0.19, 0.32, 0.40. So now I want to graph some of these values. So I'm going to I'm going to make the data set a little bit smaller so that I can see the entire graph. And what I want to think about is what should I graph? So I know that I want to be graphing the protein concentration and the absorbance. So if I think about which is the dependent and which is the independent variable, I can decide which will go on the x-axis and which will go on the y-axis. Hopefully you know that the independent variable goes on the x-axis and the dependent variable goes on the y-axis. The dependent variable is the thing that is dependent on the independent variable. So in this case, the absorbance of the the absorbance of the solution is based on how concentrated it is. So absorbance is our dependent variable, and protein concentration is our independent variable. So protein concentration should go on the x-axis, and absorbance should go on the y-axis. You may see a line at this point displayed on the graph here. You can see a red line displayed on this graph. You can also see that right now the default is to have the x-axis be the mass of the protein and the y-axis be the volume of the protein. We need to change these things so that it's graphing the information that we want to graph. So if you double-click anywhere on the graph, you'll get this box that comes up. We can title our graph here. An appropriate title for this graph might be the absorbance of different solutions based on their concentrations. And actually, if we made it a little bit more specific, the absorbance of different protein solutions based on their concentrations. So that looks good. If we double click on it again and go to axes options, we can tell it what it should graph. So here on the x-axis we said that we want it to be graphing the concentration. So we can say it should graph the protein concentration. And on the y-axis we want it to be graphing not the volume but instead the absorbance. So when we hit OK, now we can see a tiny green line has shown up almost on top of the x-axis, and that's because it's not scaled very well. If you look back and notice our absorbance values were quite small. The absorbance was never larger than 0.40, and you'll notice that the scale here goes from 0 up to 100. So all of the points are there, it's just that they're condensed into the very bottom of the graph. So we need to scale the graph so that it's a little bit more appropriate. Also, the protein concentration in our data never goes higher than 40, but on the graph here it goes up to 100. So we want to scale the graph. There are two ways to do this. We can hit auto scale, which is here, and it will do it for us. The other way, I'll show you that in a second, the other way is to double click on the graph, go to axes options, and you can say that I want the top to be a certain number, the bottom to be a certain number, the left to be a certain number, and the right to be a certain number. Generally the auto scale is easier though, so if we just hit auto scale, it scales it appropriately. So now we see this line, and actually what we want to look at the points that were graphed instead of the line. We don't care so much about connecting the points, but we'd like to see the points. So in order to see the points, again, you double click on the graph and you click on point protectors. That's going to show you the individual points. And since we said we don't care if they are connected, we uncheck the connect points box. So then when we hit OK, there are some points here. You can see 4 points, 1, 2, 3, and the fourth one is up in the very corner. And what we want to do now is draw a line of best fit. So if we go to Insert, Analyze, Linear Fit, that is going to make a best fit line for us. We can see the equation for the line in this box, which we may not need right now, but might come back to later. If we want, we can move the box around if it seems like it's getting in the way. You can click on it and drag it. And so now we want to use this graph in order to figure out something about our unknown. So in this case, we're asking ourselves the question of, if we had a solution with an absorbance of 0.36, what would be the concentration of the solution? So we discussed in class today how you would solve a problem like this. You would, if the solution has an absorbance of 0.36, basically what you need to do is look on the y-axis for the absorbance of 0.36, which is here, and then you would trace across to your line and then trace down to find out the corresponding concentration. It looks like it's about 35, but no surprise, the computer can do a better job of this. So if we go to Analyze, Interpolate, we will get this bar here that slides along the best fit line. So you can see on the bar that there is a little circle and it slides along the line. And you can watch in this box up here, as the line moves, you can see the values in the box change. So if we're looking for an absorbance of 0.36 and we want to know the corresponding protein concentration, we can move this line along until we get to an absorbance of 0.36, which you can see in the box on the top left of the graph. And so it looks like at an absorbance of 0.36, the concentration is about 35.5 grams per mil. So let's say that we wanted to note that on the graph. You can, if you just move away from the graph and click on this X box, it will get rid of that interpolate line. So keeping in mind that it was about 35.5, we can insert a text annotation. So we can say absorbance equals 0.36, the corresponding concentration equals 35.5 grams per milliliter. And now I can drag this line down. Oops. I can drag the line down to right about 35.5 to show that that is where it would intersect with the x-axis. And then I can move this down by clicking right on it. Sometimes it's a little finicky. You get the hand, and then you can move that right down so that it's pointing right to the area on the axis that corresponds to the 35.5 grams per milliliter. So you're going to need to use the text annotation when you are graphing your unknown beverages. So you should have 5 different text annotation boxes up on your graph. And when you're all finished, you can take a screenshot of your graph and insert it as an image into your Google Doc, which you will then share with me. You can do the same with your data table as well. You can have take a screenshot of your data table and insert it as an image into your Google Doc. So hopefully that's a good little tutorial to show you how to use LoggerPro. Please let me know if you have any questions.